Some shocking facts about SpaceX and how it is revolutionizing space travel. SpaceX was founded in 2002 by Elon Musk with the goal of reducing space transportation costs to enable the colonization of Mars. SpaceX manufactures the Falcon 9 and Falcon Heavy launch vehicles, several rocket engines, Cargo Dragon, crew spacecraft, and Starlink communications satellites. The South African-born visionary's ultimate goal is to enable multi-planetary human existence by drastically reducing the cost of launching material into space. With our current technology, escaping Earth's gravity is not easy and comes with a hefty price tag. For example, it will cost about $500 million to send NASA's Space Launch System, SLS, currently the most powerful rocket to ever be developed, to low Earth orbit with about 70,000 kilograms, 150,000 lb of payload. SpaceX's latest and greatest, the Falcon Heavy, can do about the same for approximately $90 million, less than one-fifth of the SLS and its equivalents. So what is the secret behind this unprecedented efficiency, and what exactly does Elon Musk have in mind for the future? SpaceX. Rocky beginnings to roaring success. In 2002, founding an aerospace technology company was objectively a high-stakes gamble. In a climate already dominated by industry giants like Boeing and Lockheed Martin, getting a startup off the ground posed many challenges, with funding chief among them. Elon Musk had thus far made a name for himself by defying the odds, having dropped out of a PhD program at Stanford after only 2 days to pursue his entrepreneurial interests during the dot-com bubble. However, early failures in 2006 and 2007 to launch beta versions of the SpaceX flagship Falcon 9 left the company nearly destitute. Musk had already invested up to $100 million of his personal finances into seeing the space technology company succeed, and by 2008 it was done or die. Fortunately, billionaire entrepreneur and venture capitalist Peter Thiel, also a co-founder of PayPal, stepped in at the last moment and became SpaceX's first outside investor. Thiel's capital breathed new life into the company's rickety legs, and progress has been steady ever since. Now, this is not to say that SpaceX hasn't had plenty of problems since its rejuvenation. If it hadn't, then it wouldn't be much of an aerospace company now, would it? Crashing and burning simply come with the territory. In 2014-15, SpaceX waged a legal battle with the United States Air Force for awarding launch contracts, essentially without competition, to the United Launch Alliance, a joint venture between Boeing and Lockheed Martin. Add to this its myriad of launch and landing failures throughout the late 2000s and early 2010s. But its successes now seem to far outweigh its missteps. The company boasts multiple governments, military and private satellite contracts, and has launched around 50 Falcon 9 rockets, some of them reused. The company is now valued above $20 billion. From all this, it is safe to assume that the future for SpaceX rests in the stars. Rinse and repeat. Turning rockets into airplanes. And the early 2000s, after realizing that purchasing refurbished Russian items to propel his ambitions into orbit wouldn't be financially viable, Musk decided to build his own rockets. The idea was to produce about 85% of the necessary materials in-house, which would help to radically cut back on production costs due to the expensive nature of subcontracting parts. The next step toward greater efficiency comes with the total reusability of the rocket. This makes complete sense as well. If you go to the trouble of designing and building a multi-million-dollar rocket, it's logical to attempt to recover the entire thing as opposed to crashing it into the ocean. Just imagine how expensive air travel would be if you were flying on a newly christened aircraft each time you took a trip. While reusability is nothing new to a material economy, it's quite a bit harder to apply to 20-story rockets. SpaceX is the first to employ propulsive landing in Earth's atmosphere. Each Falcon booster uses a combination of onboard telemetry computers, retractable grid fins and landing legs, and booster engines capable of angling their direction of thrust to land safely. On December 21, 2015, Falcon 9 made its first successful landing after several near misses earlier that year. Since then, SpaceX has landed 21 out of 26 attempts, with the most recent 17 landings being consecutive, including the Falcon Heavy. Musk's hope is to eventually be able to reuse the Falcon boosters thousands of times so as to reduce the capital cost per launch from about $60, $90 million to under $50,000. By insisting on a 100% reusable system, the only costs each flight would incur would be fueling, the price of which pales in comparison to building the rocket, and some other overhead, including pre-launch inspections, with a fairly impressive track record throughout 2017 and into 2018. It would seem that SpaceX is well on its way to meeting that demand. Cargo delivery to the International Space Station, that'll be $150 million. Beginning in 2009, NASA awarded SpaceX a $1.6 billion contract to begin resupply missions to the ISS. Coming on the heels of the Space Shuttle's retirement, this agreement marked the first time that NASA would rely on a private company to deliver cargo to the station. Over an 8-year period, SpaceX was charged with sending a minimum of 20 metric tons of supplies, including food, water, and scientific equipment, to rendezvous with the ISS in low Earth orbit. Although $150 million per mission may seem like a lot, it is a fraction of what NASA and U.S. taxpayers would pay if they were to oversee the development of their own launch and payload vehicles. NASA is also assisting SpaceX in the development of its crewed Dragon capsule. Combined with the Falcon 9, the Dragon will take astronauts to the ISS within several years, as with the far cheaper resupply missions, the development of the manned Dragon capsule is projected to cost NASA about $17 billion less than the design and construction of their own vehicle, the Orion. Per launch, it is expected that the Dragon will again be cheaper by a significant margin. It would seem that the future of space travel currently lies in a partnership between private space corporations and government agencies. What has SpaceX done that other companies haven't? SpaceX scored its first big headline in 2010 when it became the first private company to launch a payload into orbit and return it to Earth intact. Something only government agencies like NASA or Russia's Roscosmos had done before. Its upright landing and recovery of the first stage of the Falcon 9 rocket on Deck 21, 2015, was another first. Blue Origin, owned by Amazon founder Jeff Bezos, sent a rocket to the edge of space and landed it upright earlier this year, but it was a demonstration flight and did not achieve orbit. Are SpaceX rockets special? Progress in rocketry is incremental. The basic science of liquid-fueled rockets hasn't changed much since the days of Robert Goddard. And solid-fueled rockets, well, they go back millennia. The advances are made at the margins, and Musk is doing well there. His rockets are modular. The Falcon is a single-engine model. The Falcon 9, no surprise, has 9. The Falcon Heavy, which has yet to fly, will have 27 in 3 clusters of 9 engines. This streamlines production in the same way that building different car bodies atop similar chassis helps keep costs down for car manufacturers. Roughly 80% of the parts in any SpaceX rocket are made on the company's own factory floor, reducing the cost of outsourcing. This keeps price per pound of payload down and quality control in-house. One study, by NASA and the Air Force, estimated that the price tag for going from the initial design stages of the Falcon 9 rocket to its first flight was $440 million, about a third of what it would have cost NASA. How close is SpaceX to flying a crew? Very close, maybe. The company has used its Dragon spacecraft to make uncrewed cargo runs to the ISS. The Dragon was designed with crew compatibility in mind, which means the ship has already proven its basic spaceworthiness. Though it has a good way to go before its life support systems are similarly proven. SpaceX and Boeing are both scheduled to begin crewed runs to the ISS in 2017, and NASA has already designated the first astronauts who will fly in the new ships. The 2017 target could slip, and the June explosion of one of SpaceX's cargo rockets during the launch was hardly good news for the company. The recent launch of the Falcon 9, even without the upright first-stage landing, was a confidence booster. But with astronaut lives on the line in future flights, the company will have to put a string of good launches together to make up for that very bad one.